Welcome back to the Machine Learning course. If you're new here, I'm really happy to have you with us. In the previous videos, we discussed the complete roadmap of this course and finished Phase 1, where we learned how to pre-process data before feeding it into a machine learning model. Today, we're starting Phase 2, Part 1. And this is one of the most important parts of the entire course, because now we're entering the world of machine learning itself. In this video, you'll understand the 5 fundamental ways machines learn from data. We'll cover supervised learning, unsupervised learning, semi-supervised learning, self-supervised learning reinforcement, learning. Don't worry if these names sound confusing right now. By the end of this video, you'll clearly know what each one means, when it's used, and how they're different from each other. So without wasting any time, let's begin. Before moving ahead, let's quickly see where we are in the course. We have already completed Phase 1, which focused on data pre-processing. Remember, data pre-processing is all about cleaning the data, handling missing values, encoding categorical variables, scaling features, and preparing the dataset. Now we've entered Phase 2, and today's lesson is Part 1, Machine Learning Basics. This video builds the foundation for everything we'll study later. In the upcoming parts of Phase 2, we'll start learning actual machine learning algorithms like linear regression, logistic regression, decision trees, random forests, support vector machines, and many more. So today's goal is simple: understand how machines actually learn from data. In this lesson, we'll explore 5 major learning paradigms. Think of them as 5 different teaching methods for machines. The first is supervised learning, where we provide the machine with both the questions and the correct answers. Next comes unsupervised learning, where there are no answers at all. The machine has to discover patterns on its own. Then we'll discuss semi-supervised learning, which combines a small amount of labeled data with a large amount of unlabeled data. After that comes self-supervised learning, one of the hottest topics in AI today, because it's the technology behind modern language models like ChatGPT. Finally, we'll learn about reinforcement learning, where an AI learns through trial and error using rewards and penalties. Let's understand each one step by step. Let's start with the most common type of machine learning, supervised learning. Imagine you're teaching a child mathematics. You give the child a question and also provide the correct answer. Over time, the child learns the pattern and becomes able to solve new questions independently. Machine learning works in exactly the same way. Here, every training example already has the correct output. For example, suppose we're building a spam detection system. We collect thousands of emails. Each email is already labeled as either spam or not spam. The model studies these examples and learns the relationship between the email content and its label. Later, when a completely new email arrives, the model predicts whether it's spam or not. Supervised learning mainly solves 2 types of problems: classification, where the output is a category, for example, spam or not; spam disease, or healthy cat or dog. The second is regression, where the output is a number. For example, predicting house prices, stock prices, temperature, or salary prediction. So the key idea is very simple. The machine learns using labeled data where the correct answers are already known. Now let's remove the labels completely. Imagine you have thousands of customer records, but nobody tells you who belongs to which group. There are no labels, no categories, no correct answers. This is where unsupervised learning comes in. Instead of predicting labels, the model tries to discover hidden patterns by itself. One of the most popular techniques here is clustering. A famous algorithm for clustering is k-means. For example, an online shopping company wants to understand its customers. Without any labels, the algorithm may automatically discover groups like loyal customers, bargain hunters, premium buyers, or inactive customers. Nobody manually defined these groups. The machine found them on its own. That's why unsupervised learning is called pattern discovery. In real life, labeling data is expensive and time-consuming. Imagine you have 1 million images. Manually labeling every image could take months. But what if you only label 5% of them? Can the remaining 95% still be useful? Yes. That's exactly what semi-supervised learning does. It combines a small amount of labeled data with a huge amount of unlabeled data. The labeled examples guide the learning process, while the unlabeled data helps the model better understand the overall data distribution. As a result, the model becomes much more accurate without requiring massive labeling effort. A good example is web page classification. Instead of labeling millions of web pages, we label only a small subset, and the algorithm learns from both labeled and unlabeled pages together. This approach saves both time and money. Now let's move to one of the most exciting topics in modern AI, self-supervised learning. This is the technology behind models like ChatGPT, GPT, and BERT. The interesting part is that humans don't create the labels. The data creates its own labels. Let me explain. Suppose we have the sentence, "The cat sat on the..." We remove the last word. Now the model's task is to predict the missing word. In this case, the correct answer is mat. Notice something interesting. We never manually labeled this sentence. The sentence itself provided the answer. That's why it's called self-supervised learning. By solving billions of these prediction tasks, language models gradually learn grammar, facts, reasoning, and even coding skills. This learning process is called pre-training, and it's the reason modern AI models are so powerful. Finally, let's talk about reinforcement learning. Instead of learning from datasets, the AI learns by interacting with an environment. Think about teaching a dog. Whenever it performs the correct action, you reward it. If it does something wrong, it receives no reward or even a penalty. Gradually, it learns which actions are better. Reinforcement learning follows exactly this principle. There are 4 important components: the agent, which is the learner, the environment, where it operates, the actions it can perform, and the reward, which tells whether the action was good or bad. The agent repeats this process thousands or even millions of times. Eventually, it discovers the strategy that maximizes long-term rewards. Famous examples include AlphaGo, chess engines, self-driving cars, and many robotics applications. Now let's compare all 5 learning paradigms together. In supervised learning, we use fully labeled data to predict known outputs. In unsupervised learning, there are no labels, so the goal is to discover hidden patterns. Semi-supervised learning uses only a few labeled examples along with a large amount of unlabeled data. Self-supervised learning automatically generates labels from the data itself. And in reinforcement learning, there are no labels at all. Instead, the model learns from rewards received while interacting with an environment. If you remember just one thing from today's lesson, remember this. The biggest difference between these learning methods is the type and amount of information available to teach the model. Once you understand that, the rest becomes much easier. Congratulations! You now understand the 5 major ways machines learn from data. This knowledge is the foundation of almost every machine learning algorithm you'll study in the future. In the next video, we'll begin exploring actual algorithms, starting with linear regression and logistic regression, where we'll learn not only the theory but also how to implement them in Python. If you found this video helpful, don't forget to like the video, subscribe to the channel, and press the notification bell so you don't miss the next part of this course. Also, if you have any questions, leave them in the comments below. I'll do my best to answer them. Thank you so much for watching. I'll see you in the next lecture.